Wow, there's a lot of people. Hi everyone. I don't know if you can hear me. Hi. Wow, nice bagels.
Yeah, I'm just going to pull them up. Oh, they can hear, I think. Hello, everyone.
Oh, hi. Nice to see you. Yeah, so we're going to be live solving, so we have not seen the problems yet.
Nope.
Hopefully we will be able to do them, not get destroyed by them.
Yeah. Well, I suppose if there's any geometry, I can just ask you, and then that'll be all good.
Hopefully. How long is the class? It's 1 hour. And it's not exactly a class, it's more like a live solve. So it'll be more fun than a normal class. But yeah. Is it just me or was there just some background noise?
There was background noise. Now it's fine.
Hello. Okay, let's see how we're doing. Just a second. Great. Hello, everyone. How are you? Let me put this here. Great. So let me just welcome everybody to our event tonight. And actually, we're really, really happy to be collaborating with Math Kangaroo USA on this live solve. Now, you may notice already that the way that this is all designed is that if you want to chat with us during this session, just send your messages to Chat Relay if you happen to be in the Zoom meeting. And if you happen to be watching us through YouTube Live, unfortunately, there's no way that we can see your comments. So you guys are probably just having a zoo over there. But if you want to join the comments that are making it onto the screen, there's another website, I believe it's linked on the YouTube description, live.poshenlo.com/show. And then you can join in on this. But without further ado, what I want to do first is I want to introduce the representative from Math Kangaroo USA, who we're collaborating with, who's going to jump on screen and say a few words. Kasha, would you like to jump in? If you just talk, you'll be on screen.
Yeah, I'm ready. Hello, everyone. Can I talk?
Oh, yes. Oh, wait, one second. Let me adjust one thing so that the correct video is sharing. I can see from this that it's not quite sharing right. They can hear us and they can see us if they're in a certain mode. But let me adjust one thing. I'll be back in about 15 seconds.
All right, I'm waiting.
Hi everyone.
Hi, everyone.
Nice to see you.
Yes.
Wow,
Hi,
you guys are really young, 5th grade. Wow. What's up? Oh, wow.
Yeah, this is on YouTube. Your comments are going to be shared with the YouTube live stream.
Yeah, this is being streamed on YouTube too.
Terrific. So I'm back. Sorry, apologies for that. That was just because there was something on our end on our preview. So actually now in our little room that we're broadcasting to, all of us in the preview room should be able to see exactly what we're sending out. So in that case, Kasha, when you go, you will be on the screen for everyone to see. Go for it.
All right, welcome everyone. My name is Kasia Nalaskowska. I work for Math Kangaroo since 2011. I usually respond to a lot of emails sent by teachers who are interested in Math Kangaroo. And if they decide to host Math Kangaroo competition at school, I am the one who will register the center. So students like you can take the test in March. I'm very happy you registered today for daily challenge with Po-Shen to practice Math Kangaroo problems. It's a very good sign to see so many students. I've heard 700 or 800 eager students to solve math problems tonight during summer break. So I think it means you must love math. So I'm very impressed. So good luck tonight.
Wonderful. Well, thank you very much. And I'm very happy to say that it's actually not just me. In fact, there are some very interesting people here who will make it far more interesting than just watching me. The two co-hosts, Vivian and Evan, are both extraordinarily good at math. They are in high school, but when they were back in middle school, they were also doing math competitions. In fact, they did math counts as one of the big competitions that they participated in. And if you haven't heard of it before, math counts in the United States is a gigantic where people go all the way up to eventually the national level. And both of them were on their state's teams, one from Nevada, one from Pennsylvania, representing their state. That's among the top 4 in that state. But what we will do is we will all discuss together, and we will take turns among the three of us doing some of these questions, just so that they get some time on screen just to say hi. I'm going to pause for a second. If each of you just says hi, then everyone can see you, and then we'll jump back around to me doing the first question.
Okay, hi, I'm Vivian, and I'm a TA at Daily Challenge. Yeah, nice to meet you.
Hi, I'm Evan. I'm also a TA with Daily Challenge, and I like bagels. Nice to meet all of you as well.
Terrific. And hi, I'm here again. I'm Po-Shen, and maybe it was not mentioned at the beginning. I like to do math, obviously. And if you have seen me from YouTube or from other things, this is where we often will go onto this channel and discuss some math problems. And I can see that there are other people here who also like bagels, which is fun. By the way this chat is designed is that it actually is moderated. So we actually encourage people to just say things, have fun, and hopefully that keeps people more engaged in the entire lesson. Now, if there are things that are truly disruptive, those will actually get removed. But so far, I think this is okay. Bagels are quite reasonable things. All right, so now let's start doing some of these questions. I'll take the first one, and then we'll go around in a cycle. Let's go by alphabetical order by first name. So Evan will be the next one. So this one says, Sanath paddled around 5 buoys. Wow, buoy is a hard word to spell. 5 buoys as shown. Around which of the buoys did Sanath paddle in a clockwise direction? Okay, this is question 1. Hopefully I can do this one. So I'm just kind of looking around. And of course, the most complicated thing is I'm looking on this screen, which is flipped, and I'm having a difficult time understanding which is clock and which is not clock because it reflected. But if I'm looking around, so 1 is, okay, that's not clockwise because clocks don't do that. So I'm just going to draw an X. So 1 is not clockwise. Then it goes around here, and then 2. Oh, 2 does look like a clock. Yes. Okay. And then after 2, it goes around 3. 3 looks like a clock also. Okay, and it goes around 4. No, that's the backwards. So 4 doesn't work. And 5 does look like a clock. That's what clocks do. So 2, 3, and 5. I'm going to guess E. I wonder if this is right. Let's go and see. Is this E? Yay, I passed. Okay, Evan, on to you. If you have any comments on this, go ahead too.
Yeah, that was fun. I always have trouble remembering which way is clockwise for some reason. And I always have to think, there's a clock. Okay, good, it goes that way. It's convenient that in math competition rooms, they always have a clock to tell you how much time is left.
Yeah.
But the next problem, the license plate of Kengi's car fell off. He's going to be in trouble with the DMV soon. He put it back upside down. Even more trouble with the DMV. Oh, but luckily it didn't make any difference. So he's safe from the DMV. Which of the following could be Kengi's license plate? So actually, if I was on paper, I just immediately flip the paper upside down and see which of them makes sense. But I'm not. So I can see 04 NSN 40. What if I turn the end upside down? I'm just going to see what happens as I turn all of these last numbers upside down. Because I want this 04 upside down to be, I want this 40 upside down to become 04. Oh, there was a similar question. Yeah, that's why it's good to do past tests. You'll see all these similar questions. But 40, well, upside down, 40 does not look like 04. And actually, I could see that 80 does not look like 08 because if you look really closely at the TypeScript, one end of the 8, here, I can make this bigger. One end of the 8 is a lot thicker than the other end. So if you turn it upside down, it won't look the same. But actually, 06 and 60 and 09, if you turn 09 on its head, it looks just like 60. I mean, with messy-ish handwriting. And actually, HOH upside down, it's pretty easy to see that looks like HOH. So B is what I'm going to guess. And let's see. B. Oh, 60 ho 09. Hooray! It's B.
Good job.
Yeah.
Nice. Okay, I guess it's my turn now. So that was a very interesting problem. At first I got trolled because I thought choice 3, like the 8-0 might work, but then I had to read the letters and find that the letters did not look the same upside down. So that was an interesting problem. Okay, next problem. This one looks a bit more complicated. Let's see. Okay, so there's 5 empty spaces and 4 of them have plus signs and 1 has a minus sign so that the equation is correct. Okay. So I guess like if I think about like what is happening here overall, I'm basically adding, okay, so how many numbers are there? 1, 2, 3, 4, 5, 6. There's like 6 numbers on this left side, and I'm basically adding 5 of them and subtracting the 6th one. For example, like if I just randomly chose a place for the minus sign to be, like if I randomly put the minus sign there and then put the other plus signs in all the other boxes, then basically what I would get is 6 plus 9 plus 12 plus 18 plus 21 and then minus 15. So basically I'm adding all of them except for the 15 which I'm subtracting. So basically I want to just find a way to choose one of them that I subtract so that the sum is 45. Now let's see. Well, like going off of this example here, oh wow, a lot of people are saying it's choice D. Well, let's see if we get choice D. If we do, then that would be great. Okay, I like how Vincent's saying you subtract one of them twice. So yeah, that's exactly what I was thinking. So you see when you add all of these 5 numbers, 6, 9, 12, 18, 21, and then you subtract 15, that's basically just the same as adding all of them, 6 plus 9 plus 12 plus 18 plus 21 plus 15, and then subtracting 15 twice. So subtracting 2 times 15. And the reason why this is nice is because I know what their sum is. I know what the sum of all the numbers is because I don't have to guess anything there. So the sum of all the numbers, well, let's see. What is a good way to do this? I guess we could use arithmetic mean since they're in an arithmetic progression. So their average is like 27 over 2 since, actually no, I can just pair them up. So 6 plus 21 is 27, 9 plus 18 is 27, 12 plus 15 is 27. So they all add to 3 times 27 equals 81. So now I basically have the equation 81 minus 2x equals 45 if x is the number that's being subtracted twice. And let's see, if we solve this, we get 2x equals 36 and x equals 18. So now what exactly does this x mean? Well, it's the number that we are subtracting. So like in this example, x is 15. So now if I was to make x 18, let me erase these plus and minus signs. You guys are exactly right. I would put the minus sign between 15 and 18 because that way 18 is the one that's being subtracted. So we have 6 plus 9 plus 12 plus 15 minus 18 plus 21. And the answer is D. Good job, everyone. Cool. Wait, oh yeah, I should check to see if this is actually correct. Let's see. It is, yay. I mean, you guys all got the correct answer, so good job.
Cool. Is it me now?
Yeah, I think.
Okay, that's me now. Let me hide the chat for mine just very briefly because I can see that it's blocking something right now. So what's this question? The distance between 2 shelves in the cupboard in Monica's kitchen is 36 centimeters. She knows that a stack of 8 of her favorite glasses is 42 centimeters tall, and that a stack of 2 glasses is 18 centimeters tall. What is the largest number of glasses that can be stacked and still fit between 2 shelves? Okay, so I have to actually read this and understand what's going on. Because first of all, the question looks somewhat familiar because we have been doing a bunch of Math Kangaroo live solves. And sometimes there are questions that it looks like what Math Kangaroo does is on the different levels of competition, they will go and put twists on the questions to get harder and harder ones on different size, on different levels. But so when I'm looking at this, I need to go and read this to make sure I understand this particular level's question. Oh, I see that there are some people who have been typing things. And since the flow has slowed down, I'm going to put the chat here, which is now dangerous because it's going to speed up again. But let's see. So the difference between the two shelves is 36. We got 8 glasses is 42. That's 42. That's 18. Okay, I guess the question is just to figure out how much I can stack up to get to 36, right? So if 2 gives me 18, 8 gives me 42, then this gap here is 6 classes. 6, all right, plus 6 classes is equal to plus how many centimeters? Well, it goes from 36 to 42. What's that? Oh, 6? No. It goes from 18 to 42. What is the distance between, what is the difference? 42 minus 18. Can any of you help with that? You're probably better at subtracting. Is it 24? Yes, I see that thing is coming into the chat. That's good, 24 centimeters. And it looks like basically everyone except America likes to use centimeters. We somehow use inches over here. Anyway, so now I see 1 glass is equal to 4 centimeters. We see that. I think I saw some people comment that earlier. So if I do plus 1 glass, that's equal to plus 4 centimeters. And so now the only question is just, well, how much can I go up to get to 36 centimeters? So if I'm at 18 centimeters, well, how much? Oh, interesting. It's going to be a fraction in the sense that if I'm at 18, how many more centimeters do I get? Between 18 centimeters and 36 centimeters, how many do I get? I guess that's 36 minus 18, which is, I guess, 18 centimeters. Is that right? So I get 18 more centimeters up to the 36. So let me see if there's another picture. Usually there is. So if I want to go up to 36 centimeters, whatever that means, I'm just randomly drawing this line. I don't exactly know if it should be cutting through there or not. If that's 36, if this is 18, then I can go up by 18 centimeters, which is not a multiple of 4. That's equal to 4 times 4 centimeters plus, plus 2 more centimeters. So that means that I get 4 more cups. And if originally I had 2 cups and I add 4 more cups, then the total number of cups I can squeeze down is 2 plus 4, which I think is 6. Let's see, is that one of the choices? Well, 6 is a choice. I wonder if the answer
Yeah, I
is
think I agree because okay, I did it this other way where basically you just notice that it's an arithmetic sequence. So if you add 1 more cup, it's going to make the height go up by a certain amount, and it's always that same amount. So there's an arithmetic sequence where the second term is 18 and the 8th term is 42, and then you just find that the common difference is 4, and then find that 6. I think 6 should work because it would give you a height of 34.
Yeah, great. Thanks. That was quick. I guess next up.
Hi. Yes, that was a neat question. Are you able to hear me all right?
Yeah.
Cool. Okay. So the next question says, on a standard die, the sum of the numbers of dots on opposite faces is always 7. 4 standard dice are glued together, as shown. What is the minimum number of dots that could lie on the whole surface? Well, actually, the inner 2 die, it doesn't matter. We're always subtracting 7 from the, actually, let's consider the sum of the dots on all of the die, and then try to subtract the maximum number possible, the numbers wedged between all the dies here that are not on the surface. Well, for these middle 2 die, the numbers on this side and this side, and the numbers on this side and this side, they're going to sum to 7. So we're always going to have to subtract 14. But then now we want to maximize the number of dots on the lefternmost die's right side and the rightmost die's left side. And that's simple. We can just turn them with 6 dots facing inwards. So we have 6 dots subtracted here, 6 dots subtracted here, 7 dots subtracted for each of these. How many total dots subtracted is that? Yeah, like Anson and Aryan are saying, it's 58, because the total sum on all of the dies is going to be 7 times 7 times 7. Wait, sorry, 7 plus 7 plus 7 times 4, which is 84. And then you subtract off 6 twice and 7 twice, and you get 58, which is D. Ian says you could glue the 2 6s together. Yeah, that's what we did. We took the 6s here and glued them, the 6s for the outermost dies, and glued them. Yeah, and let's hope the answer is D. And it is, hooray!
Yay, okay, so that was a great explanation. I basically did the exact same thing. So I don't really have any comments here. Okay, next problem, let's see. Wow, I always get the really long ones. Okay, let's see. So we've got several positive integers smaller than 7 on a piece of paper. So aka they're like 1 through 6. Or some numbers that are between 1 and 6 inclusive. Okay, and then some of them are crossed out. Wait, no. All of them are crossed out and replaced with their difference from 7. Okay, so like if we have x, then x is replaced with 7 minus x because x is less than 7. So also, the sum of Werner's numbers was 22. So like the sum of all the first numbers, like the x's, was 22. And then the sum of all the 7 minus x's was 34. So okay, let me just like make this a bit clearer. So we have like 2 columns of numbers. The left column is like the original numbers. And then the right column is like the changed numbers. So we have like A, B, C, etc. And then they're changed to 7 minus A, 7 minus B, 7 minus C, etc. I don't know how many there are yet, but we'll just put some dots there. So the original number is summed to 22. So I guess I should write a 22 down here, although it's kind of hard to see. And then, wait, let me actually move this a bit. So it'll be easier to see. Okay, and then the changed numbers sum to 34. You add them all up. Now, okay, something really interesting about this is that I don't know if other people did this too, but if you look at each row individually, the A plus 7 minus A, that will add to 7. And the B plus 7 minus B, that will also add to 7. Same with the C and 7 minus C. So basically every row is giving us a 7. And if we look at the total sum of all the columns and rows, that's 22 plus 34, which is 56. So basically we have 7 times number of rows equals 56. Since each row contributes 1 7, and then the number of rows, which is the number of numbers, is 8. So it looks like, yeah, you guys basically did the same thing. You just divide by 7. Yeah, awesome. Okay, so we will get the answer of 8. Yay. Let's see. And the answer is 8. Let's go.
Cool. Okay. I guess that's me next. Oh boy, these questions are sometimes quite hard. I see in how many ways can something be done? And sometimes that's slightly scary because you have to count it very carefully. In how many ways can the shape on the left be completely covered using 9 tiles like the ones on the right? So the first thing I want to check is, does completely covered mean that I have everything exactly covering, or can there be stuff like sticking out? For me, I just want to know how many different blocks are there in this at all. And I see right away this is 3 hexagons, and each hexagon has 6. So that's 6, 6, 6. There are 18 little tiny triangles, and 18 is 9 times 2. So that means that I actually have to have a perfect covering. So now the question is, how many ways can I actually put all that down? Wow, this is tricky. Let me start by thinking about some cases, because that's what I'll try to do from here. So let's start with the left side. So if I make one of the pieces like this, that's going to be my first case. What if I do that? I wonder what else we can do if we continue. Oh, interesting. So once I put that down, there's something that's forced. You see, this one here, I have no choice. That one has to be part of this one over here. Okay, so that has to happen. And also this one is forced because that little triangle here forced me to go that way. And that's interesting because now I just saw that if I make this one of them, then I will be forced to just put the rest of it down, just like that. That's interesting. I wonder what would happen. And I found it interesting because that's a hexagon. So it's like this hexagon here has its own behavior, and that own behavior, this is here, it forced all of these, and I still see 2 more hexagons that can do interesting things. But the next thing I'm curious about is, what if I had a different case? The case is called this particular triangle here. It's going to be part of a diamond that either goes down or across. So one case is it goes down, the other case it goes across, and there's no other cases. So let me try the next picture. What if it goes across instead? Oh, this is nice. Now I'm going to chase this around. So now over here, this piece, I also then am forced. I've got to go that way. But now I don't look quite so forced. Am I forced? Oh, this is an interesting question. Wow. I like this. So there's a bunch of cases to play with, actually. So if I do this, I have some more stuff I can do. Okay. Interesting. So one thing I could do, and by the way, I still need to have, over here, I still need to think, what would I do to finish this? What would I do to finish this? Let me finish this case first, because now I see that it's not going to be a straightforward multiplication. Originally, I thought we were just going to multiply. Like originally, I thought you either put this way or this way. There's two choices, and this thing does something, that hexagon does something, that hexagon does something. I was going to do 2 times 2 times 2 and get 8. But then it turns out that you can do more, because it doesn't have to be that the hexagon stuff stays only inside the hexagon. They can spill out. For example, when I look at this one, now I want to know how can I finish this. You see, over here, if I try to make something cross between, I'm going to use red because that's not allowed. You'll see why. What if I try to do that? Why won't that work? Can anyone type in the chat and tell me why that won't work? This is actually useful because I'm going to use this to say that splits the problem into some smaller things. Because I broke the chain, that's not really the issue. It's like, why is this not okay? It takes one triangle from both. Yes, there's an extra triangle. It's because then up here I get a contiguous, meaning all connected. I get 5 things. And 5 things here is an odd number. So I can't make this out of these nice diamond shapes anymore. So I cannot, right? This one won't finish because I can't use a bunch of these even coverings and fill this odd part. So that means that this part is not okay. I cannot do that. And instead, the way I'll think of it is that it actually splits. I'll draw this line here to indicate that then I'll do something up there and something down there. And in fact, the something up there and the something down there, the possibilities are either there's 2 choices here. And I say 2 because it's like whether up there, it looks like this, and then all the other ones going around, or whether it looks like these 2 and the others going around. So there's 2 choices to finish how that top part goes. And there's, let's use a different color. So there's 2 choices to figure out how the top part goes, times 2 more choices to figure out how many ways the bottom one goes. And in this case now, I've dealt with the case where I have a vertical at the very beginning. And if it's a vertical at the very beginning, there's 4 ways to finish this, 2 times 2. Do people agree with this? This is what I mean by when you do a counting problem, you have to be very, very careful not to overcount or undercount. So I'm splitting very carefully into cases. The first case was I used this vertical thing. And if I use the vertical thing, there's 4 ways to finish it. And now let's go to the other case. The other case is I don't use the vertical thing. So now I got this. But now I also have 2 cases. So the way I'm seeing this is that one of my cases is if I do this piece where I'm basically asking, where is this triangle going to go? This triangle here is either going to go with something down or with something across. The down one I can deal with later because I think that'll have more choices. But I'm going to start with going across like this. Suddenly, that's interesting because I get to chase this thing all around. Because now I look at this little triangle here, it has no choice. It has to go up that way. And then this little triangle has no choice. It has to go down. I think this feels sort of like a snake, because I keep finding out that things are forced. This one here is forced. It has to go down. Hopefully I have enough colors. And then I can go back over to here. This one's forced. It has to go down. Forced means there's only one thing that is adjacent to it. Okay. And then now this guy's forced. It has to go across. And then finally, there's only one thing left. So I'll put something there. So what I've just found out is if this piece here is like that, then there's one more way, right? If I put that piece across, there's one way. So I'm going to remember there's this one way. And then the only other question is, what if it doesn't go across? What if it goes up and down? Well, if it goes up and down, doesn't that look familiar? Have we just done that? Does anyone remember? What if this thing goes up and down? If this thing goes up and down, I think we just saw that over here. A situation where the left hexagon got entirely filled, and the question was, how many more ways can I finish? Whenever the left-hand hexagon is filled, then there are exactly 2 times 2, which is 4 ways to finish the whole thing. That's right, Eric. Thanks for saying this. Eric Chu said that's one of the cases from before. So that means that if I was instead making this guy go up and down, and if it had happened to go up and down, then I get +4. So I have 4 ways, +1, +4. I'm going to go with 9. Is this right?
Yeah, I agree with
I
that
think so.
answer.
Yeah.
Yeah, okay, so anyway,
This-
Professor Doe got it correct. I think like I did it basically the same way, but I kind of divided it into 2 cases. So like the left case, you can kind of see it's like symmetric. Well, they're both kind of symmetric, but in the left one, like there's this inner hexagon which has like 3 things all like pointing inwards, and then on the outer 3 hexagon shaped things there are like 2 of them kind of coming in from the sides. And then in the second case, it's basically just like each of these 3 hexagons is its own thing, like everything is contained in that one hexagon. So like there's the orange hexagon, the purple hexagon, and the blue one, and each of them has 2 ways because you can rotate the diamonds like 2 different ways. So it's 2 times 2 times 2 for the second case and 1 way for the first case. So you get 8 plus 1.
Yeah, I actually really like that way and found it too. It's like you can make cycles inside the hexagon, or you can latch each of the 3 hexagons to each other.
Man, you guys are so clever. This is why I always like to do the live streams with them instead of just myself. Great. Evan, go for it.
Okay, let's see the next question. Jenny decides to enter numbers into the cells of a 3x3 table so that the sum of the numbers in all 4 possible 2x2 squares will be the same. The numbers in 3 of the corner cells have already been written. Okay, 2, 4, and 3. I'm also going to move chat down just a little bit so we can see all the numbers. The numbers in 3 cells have been written. What number should she write in the 4th corner cell? Now, if I had to guess, and just a completely uneducated guess, I would guess whatever 20, which is the average of 1 through 9, 20, the average of 1 through 9 is 5. 5 times 4 is 20. If I was really pressed for time, I'd guess 20 minus 2 minus 4 minus 3. Okay, and I'd be wrong if I was really pressed for time, because that's not a number from 1 through 9. Actually, Vivian, my whiteboard software appears to have eaten too many bagels. It's taking a bit of a break. Do you think you could take over?
Okay, sure. Wait, okay, yeah. Maybe I'll take over for this problem while Evan fixes his whiteboard software, because apparently his whiteboard software got addicted to bagels just like him and is not here for the live solve. So anyway, okay. So, okay, Evan did say something interesting about like educated guess, like if he was really pressed for time, because I think he's thinking about symmetry. Like maybe we can make some sort of equations and maybe we can kind of like do stuff with them and maybe there will be some symmetry. So let's see. So the 4 possible 2x2 squares. Well, one of them is this and one of them is this. They're basically just like kind of on the corners. And then one of them is like down here and one of them is on the bottom right. I'm just kind of like drawing them for visual purposes. Okay, so let's see. The sum of the numbers in all 4 possible 2x2 squares is the same. Well, okay, I noticed one thing. So, like all of the squares include this middle square, right? Like this one that's marked with an X. So if they all include that, then subtracting it from all of the 4 sums will not do anything. Like it will leave them all the same. So basically, actually, you know what? I'll like place some variables on this diagram because that might make it nice. So let's let this square be A, this one be B, and this one be C, and this one be D. So like A, B, C, and D are like the squares forming a diamond. So, oh, someone just said the middle is 5. That's interesting because 5 is like the average of all the possible numbers. So that's kind of interesting. Anyway, oh, Ian said it doesn't matter what the middle one is. That might make sense because the middle one's like added, it's being added to all 4 sums. So yeah, that might be true. Anyway, let's write out some equations. So since we're just like not even thinking about the middle square, we have the equations 2 plus a plus d. This is like the other 3 in the white square. And then the other 3 in the purple square, 4 plus a plus b. The other 3 in the yellow square, 3 plus b plus c. And the other 3 in the blue square, question mark plus c plus d. So all 4 of these are the same apparently. And let's see. So I guess like if we maybe first look at the top 2, then we could figure out something about b and d, because let's see. If 2 plus a plus d equals 4 plus a plus b, then we get 2 plus d equals 4 plus b, which means that d equals 2 plus b. And then let's see. If we look at the middle 2, then we get 4 plus a equals 3 plus c, because they both include the b, so we can just kind of like subtract b from both of them. So I guess this gives us c equals 1 plus a. Interesting. And then finally the last 2, because we want to kind of like get all 4 of these equations involved. So let's involve the last one. Oh, this one has the question mark. Oh, okay. We don't like the question mark very much. Okay, so we would get, let's see, 3 plus b equals question mark plus d. Interesting. Okay, you know what? I think I'm going to have to use the fact that every number is included once. Like every number from 1 through 9 is included once. So let's see. We know that d equals 2 plus b and c equals 1 plus a. You know what? I'm going to, okay, Peter says you can use all the equations and solve. Well, the thing is, I think I have more variables than I have equations. Like I don't have that many equations. I have basically 3 equations because I have 4 expressions that must all be equal. So like I have 3 equations basically, but I have 5 variables. So I don't think you can directly solve like that, but we can use the fact that we only have the numbers 1 through 9. And actually, because we don't have 2, 3, and 4 anymore, since they were already used, we basically only have 1, 5, 6, 7, 8, and 9. So, okay, people are saying to use substitution. We kind of already used substitution to get these 2 better equations, d equals 2 plus b and c equals 1 plus a. I'm calling them better equations because they're easier to use. So, let's see. So it looks like a and c must be consecutive, and then b and d must be apart by 2. And then, okay, so 3 plus b equals question mark plus d. Oh, wait. Oh, okay, wait. I think I see something that we can do. So let me draw a long arrow because there's not much space on this whiteboard. But you see how we have 3 plus b equals question mark plus d? We also have d equals 2 plus b. So using those 2 equations, I think we can substitute and get 3 plus b equals question mark plus 2 plus b, which means 3 equals question mark plus 2. Wait, hold up. Wait, this looks not correct. Hold up. So, wait, and then I get 1 equals question mark. Wait, did we just find the answer? Hold on, this feels too easy. Wait, like, can you guys check to make sure I did not do something crazy? Like, I basically took this top equation in pink and then this bottom one in purple and substituted and got 3 plus b equals question mark plus 2 plus b, since d equals 2 plus b. And then that just gives question mark equals 1. Which is kind of nice because like 1, 2, 3, 4, the corners are all consecutive. That's kind of nice. Okay, let's see. Is the answer really 1? Looks like people are saying it is. Oh, nice, it is. Cool.
Whoa, I just saw this thing and I was first of all, I saw a lot of equations. So that's good. You got it. I think there's another way that one can look at it.
I think there is another way. Anyway, you can go
So
on.
I'm just curious. So I was looking at this and I was thinking, I've got this stuff here, right? So if every 4 things add up to the same thing, then these 4 added together are equal to those 4 added together. Is that right? So those 4 equal to those 4. But there's something in common. So since there's that thing in common, that means that the sum of the top two equals the sum of the bottom two. So that means that the sum of these two and these two is the same, whatever it is. Okay, that's going to tell me something. And this looks interesting because there's some symmetry here. If these two add to the same thing, actually also these two add to the same thing as those two. But already from this, like something plus 4 equals something plus 3. If this thing here was an x, oops, that's a very big x. Let's do this. If this thing here was an x, that x is not bright enough. Brighter x. If this was an x, can anyone tell me what goes here? So I'm just saying that I see some people like the moderated chat, but if this thing here is 4 plus x equals something plus 3, then this thing's x plus 1. Yeah. Then this guy's going to be x plus 1. Wait, that's really powerful. Can anyone see what I should do next? So like I found out that the sum of these two things equals the sum of those two things. And I got this amazing fact that that's x and that's x plus 1. I have no idea what x is. I have no idea what x plus 1 is. But then what should I do? Somebody said, wow. So there's also another thing I can do. I can do the same thing over here, right? Because over on this side, it's also true that this thing adds up to the same as that thing. So that means that, again, there's an overlap here. So that means that those two on top add to the same as those two on the bottom. By the way, what Vivian was doing is like doing it with letters. I was just doing it visually. But now I know that the sum of these, oops, that's the wrong pen. The sum of these two things and these two things have to be the same. Aha. So I have a 2 plus x, and that is something plus x plus 1. So what could it be? That means that it has to be 1. But of course, I mean, I cheated because I got to watch while Vivian was thinking about it. It's a lot cheated in the sense that it's a lot easier to do it if someone else is thinking. And then I was also, how do you solve this problem? But yeah, here's a way to do it.
Wait, I think I found another way to do it. So
Another way.
So basically, you do what Professor Lowe is doing, but instead of considering like the squares that are side by side, you consider squares that are like opposite corners. So when you add them up, you get like the sum of the opposite corners plus all of those 4 squares that form a diamond plus 2 times the middle, and then that's also equal to like if you consider the other 2 opposite corners. So basically, you get that the sum of these 2 opposite corners equals the sum of those 2 opposite corners, and then you get 2 plus 3 equals question mark plus 4. Anyway, if only I had seen this earlier.
This is great. So there's 3 ways to do this. Meanwhile, I saw that somebody asked, what is that star? The way that our system works is if you make a comment that somehow the moderators think is particularly good, they'll force your message through and they'll give you a star along the way. This is how we incentivize good comments. Meanwhile, I'm just looking at this. I can see in our own presenter room how ready Evan's equipment is. Evan looks like he's still battling the Wi-Fi. Oh, there's a thumbs up. Does that mean he's in?
Yeah, I think so. I'm using a completely different whiteboard software now.
Oh, nice.
Jump in, Evan.
Okay. Wow. Sorry for leaving that really hard one for you. It did not look fun, as much as I could tell.
Wow, amazing. Wait, well, you have like a paragraph long question, so.
Okay. It looks like logic, though, and that's fun.
Yeah.
So Mowgli, creative names, asked a zebra and a panther what day it is. The zebra is a pathological liar on Monday, Tuesday, and Wednesday. So that's like beginning of the week grumpiness. Very understandable. And always tells the truth on the other days. The panther lies on Thursday, Friday, and Saturday, and always tells the truth on the other days. So the panther is grumpy that it's going to be the weekend. Maybe they have a bad weekend job? I don't know. The zebra says, yesterday was one of my lying days. The panther says, yesterday was also one of my lying days. Oh, this is fun. What day it is? What day is it? Okay. Zebra lies on Monday, Tuesday, Wednesday. I'm going to open a new here and make a chart. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Oh, okay. Yeah, Saturday and Sunday. And I'm going to mark down whether or not the zebra lies and whether or not the panther lies. Okay. Zebra here and panther here. Okay. And now I'm going to switch colors because this is getting boring. All these very same colors. So let's see. Zebra lies on Monday, Tuesday, Wednesday. Is that it? Okay, yeah, I think it is. So I'll just put a rainbow for when the zebra lies. Zebra lies Monday, Tuesday, Wednesday. Panther lies Thursday, Friday, and Saturday. That's not very visible. So I'll just use pink instead. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Right. And I think, sorry, I undid that. But I think it should be simple enough just to go through what day of the week is it and see if anyone's lying. And it will have to be on the edge, I think, because it will have to be either Thursday or Sunday, because one of them is telling the truth that yesterday was their lying day and today is not. So if it's Thursday, the zebra will say, yesterday is my lying day. And if it's Friday, and if it's Thursday, the panther will also say, yesterday is my lying day. Okay, what about if it's Sunday? Okay, yeah, Sunday doesn't work. Only Thursday will work. And Sunday doesn't work because the zebra will tell the truth that yesterday was not a lying day because it's Saturday. So yeah, it has to be Thursday. And let us see if it is. I sure hope it is. Yay, it's Thursday. Hey.
Yay, awesome.
Yay! And one thing I also want to say, I saw people commenting in the chat. It's because Evan is currently doing some heroics. The reason Evan's thing was blurry is because there is some work going on the Wi-Fi or the internet company around where he is, and he has managed to heroically do this live solve anyway, even through it. So please bear with us.
Yeah.
Nice. Okay, I think it's. Wait, yeah, what? You can go.
Oh, never mind. No, I was just gonna say, I think there used to be a commercial like, what day is it? It's Thursday, and then something like, Miller Thursday? I don't know. It was random.
Well, it's Friday today.
Yeah.
Anyway, that was a very interesting problem. Like, basically, I just kind of found out that, like, for both of the two animals, either today was lying day and yesterday was truth day, or the opposite. So, like, exactly one of today and yesterday was a lying day. Anyway.
Cool.
Next problem.
Is it actually my turn at this point? I don't remember.
I mean, okay, so I took over for Evan and then Evan went. So like, I guess maybe you can go, like, because you haven't gone in a while. So I guess you can just go.
Okay, now let's do this. I mean, I'll go, but I'm guessing since it's problem 29, that might be towards the end, and that also means it might be hard. So you guys can help me as we think about this. It's a geometry. All right, an isosceles triangle ABC. All triangles are ABC, unless they're PQR or something, with AB equals AC. So I have this, with my chat, it's a bit hard to see. There's a B down here and there's a C over here. Okay, so these are the equal lengths. It's split into 3 smaller isosceles triangles. Oh, cool. So when you do this, then you have another isosceles triangle. And then when you do this, you have another isosceles triangle. That is true, right? And the things that look equal are equal. I think that's what this is saying. Note that the diagram is not drawn to scale. Okay, it doesn't quite look equal. So I guess that's what that means. What is the size in degrees of angle BAC? What? This is possible? Okay, interesting. Oh, I get it. It's because this is isosceles. That's what it means. So it's got one isosceles triangle. Wait, what? It's split into 3 smaller isosceles. Oh, wait. It's not the things that look equal are equal. Let me mark the things that are equal. So we have AD is DB. So these 2 things are equal. Okay. CE is CD. And those 2 things are equal, what I expect. And also BE is EC. Okay, so those 2 are equal. All right. Here, I like angles better than lengths. Let me try to do something called angle chasing. So this is equal to that. This is equal to that. And this is equal to that. Is that useful? Oh, I see some relations already. I'm going to start writing some letters because I see that over here, there's an angle and this guy adds to 180 with that thing, but that thing adds to 180 with both of these. So this guy here is exactly double of either of those. This is a standard fact. That's called the exterior angle theorem, which is that if I have an exterior angle like this, it's always the sum of the two remote interior angles. That's what it's called. So I feel like calling the yellow things x's. And now the purple things are 2x's. Well, at that point, my angle chasing idea is telling me I can label more stuff. Angle chasing to me just means label everything you can possibly label. So I'm now over here. And oh, wait, I've got the same picture again. That's a 2x. And then over there, those two are the same. So those are also x, right? The same thing just happened, which is these two remote interior angles add up to the exterior one. And so each of these two things, even though it's green, well, it's still the same as x. I think we should be able to solve the problem now. Because at that point, I can use like sum of the three angles of a triangle is 180. I can use it here. And I can also use the sum of the angles is 180 there. So hopefully that will solve my whole problem. Let's find out. Can anyone tell me, if I have a 2x, what is this in terms of x, this little thing that's left? Oh, actually, people have even better ideas. People have totally even better ideas. So first of all, it is 180 minus 4x. That's because it's 180 degrees total minus both of the other little angles, but it's also something else. People said it's also x. It's because the whole thing was isosceles to begin with. And if the whole thing was isosceles to begin with, well, then I have an x and an x, and that's supposed to be equal to the x and the x. So that means 180 minus 4x is x. That means we can find x. Do I care about x? I do. X is BAC. Then I'll be in great shape. I just need to know what x is, and I'm done. So that means that 5x is equal to 180. So if I divide 180 by 5, the way I usually do that is I multiply it by 2 and divide it by 10. Dividing by 5 is sort of like dividing by 10, but that's dividing by too much. So you got to times 2. So that's going to be 36. Because if I divide 180 by 10, the 0 goes away, and then times 2 gives me 36. And I'm going to go with E. That right? Wait, I see that my co-hosts have something looking pretty interesting on their screen.
Wait, okay. So basically, I just did the same thing as you, and then I just drew this star because I really like 36, 36, 108 triangles. They're very nice. For example, like a 5-pointed star, like it actually has these triangles in it. It's very cool. And they're also, like, you can find them in pentagons, I think.
Wow,
I don't know. They're
that's
just
incredible.
very cool. It also relates to the golden ratio, but that's off topic. Anyway, this is a very nice problem. I kind of just like used like angle chasing to show that those 4 angles were equal, just like Professor Lowe did. And from there, you can just make equations. It's very nice.
Wow. Okay, that's good. That's good. I'm also giving all these stars out now because somehow people said stars. So I started having some fun, and that's very nice.
Sorry.
Okay. Well, that's neat. And I mean, but as I was doing this problem, I could see, because in our own presenter room, we sort of can see each other's screens as it's going. Evan, did you have something you wanted to throw in?
I was just doing standard run-of-the-mill angle chasing. So yeah, that does work. I was kind of hoping it'd be something fun where you end up, after doing tons of angle chasing, with 180 equals 360 minus 180. That would have been kind of funny. But no, this time it gives you theta.
Yes, that's
Okay,
true.
nice.
Sometimes when you angle chase, you
Yeah.
find something interesting, like exactly as Evan said, you get to a conclusion that 360 is 180 plus 180 or something like that. That's equivalent to your statement. And while that is a true statement, it is useless. So
It's always
okay.
sad.
Cool. Well, that actually finishes, when I'm looking at my own list of problems we have here, what happened is we always go over some problems that were selected beforehand. Oh, I think we should probably have said, if it wasn't clear by now, which is almost the end of the live stream, if it wasn't clear, none of us had looked at the problems beforehand. We did that on purpose. The purpose of a live solve is to make it so that you guys can see if somebody is trying to look at questions for the first time, how will they actually be able to figure this out? And so that actually finishes the official part of this program. I should say, if you happen to like the way that this is done, you can see all of the work that we do. We actually teach all of our online classes exactly that way. That's live.poshenlow.com. And we're really proud and happy to collaborate with Math Kangaroo and use that exact same system, which you see here, to run these live solves with them every 2 weeks. Now we're going to have another session in 2 weeks with all of them. It will be a different level. We're going to move down, I think, in grade levels to grades. I think it's 5 and 6. If this was 7 and 8, it has to be 5 and 6. That's the next spot. So we're
It's
gonna
funny
have
though, because like a lot of you guys are apparently like 5th graders or 2nd graders, like, and you guys are doing grades 7 and 8. That's kind of funny. And then like next time when we do grades 5 and 6, I wonder how small those kids will be. Those
Oh
are
my
like
gosh.
elementary
That's
school.
true. That is cute. Meanwhile, I do want to say, would our host from would our partner from Math Kangaroo like to make any comments? It's entirely up to you, Kasia, if you want to, and then we'll continue to close at the end. But if you'd like to, go ahead, and you'll be on screen.
I really appreciate what you do. Thank you a lot, Daily Challenge team, Po-Shen, Vivian, and Evan for solving Math Kangaroo problems tonight. I hope to see all of the 7th, 8th grade students in, I think, October 7th. That's the next session for them. So I hope they enjoyed tonight the problems. Thank you.
Yes, that's fantastic. And thank you so much for being here as well. I actually want to say something here. If you don't do Math Kangaroo, you should. When we first encountered these questions, when I first encountered these questions, my immediate reaction was that these are the most creative math contest questions that I have seen. I'm not just saying that because we're here working with you. Actually, it's the other way around. We're here working with you because I observed that. And what I mean to say is that sometimes when people do math competition questions, they look very standard. You can just look at it and say, oh yes, it's that kind of problem or that kind of problem. But then here suddenly we get Mowgli and some lying animals, panthers or something, and what in the world is going on? And I find that these are very creative. So I do strongly recommend, no matter where you live in the world, as you can hear by now, they have many different levels. You should just go and take the one that's in your level. Strongly recommend it. And that's the other reason why Math Kangaroo is the competition that we're doing so many live solves with, because we found out that it's a never-ending supply of all of these very interesting questions. Now, with that, we actually have maybe about 5 more minutes. So what we do sometimes when we're at the end like this is, do people have any random questions? If you have random questions, you're welcome to ask them into the chat. We have here 2 incredible high school students who are here that can also answer questions about all kinds of things. I see something already. Ethan says, how to avoid sillies. Would our guest co-host like to add anything about that?
Wait, avoiding silly. So like, I don't know, you just kind of do a lot of problems and then you learn to like avoid mistakes that you made before. And it just kind of comes with practice. I'm not really sure if there's like a concrete piece of like advice I can give, but yeah.
Yeah, I mean, any advice we'd give is probably, or at least possibly, not going to be suited to you. But I know what, at least I do, is I know some people like doing the questions like once and then going over them to double. I really cannot get much done double checking. I just make the same mistake the second time, even if it's something completely stupid, like 53 plus 77 is odd. I don't know. I make the same mistakes, even if I solve them a different way. I don't know how I do it, but I managed to do it. So I just go through them very slowly and only go through them once. And I guess that's worked out all right. But obviously you'll have to do lots of practice yourself to find what works.
Yeah, so for me, when I was doing these things, I would try to do every question 2 different ways. I guess I was going quick and I would try to do everything with 2 totally different ways. But everyone has their own strategies. Meanwhile, there was a question, why is there a chicken on your screen?
Oh, that's just there for fun. I like drawing chickens in my notes and on paper. Sometimes if I'm feeling ambitious, I'll draw a duck, but they're hard.
Very good. People find it tasty.
Okay.
Another question, some people commented, how did you get so good at math? I mean, would the 2 of you like to answer anything like that?
I don't know, you just kind of do problems and then you like get better. It kind of helps to like also enjoy math. Like I think you end up doing more math and having more fun if you actually enjoy it. So like find a part of math that you really enjoy and like do it and you'll somehow get better.
Awesome.
Yeah.
I'm just like throwing the questions as I see them. Benny Z says, you made a pie in the background with lights.
Oh, yes. It lights up, but I turned it off for the live solve so it wouldn't get in the way. But I can leave it on now.
Fancy.
You should just like throw it on whenever you're doing a circle problem and just like, boom, the pie shows up.
Yeah, draw the circle around the pie. That
Yes.
sounds like a good idea.
Sydney has a question. How to simplify problems? Do people have any thoughts on this?
It depends a lot on the problem. But
Fiona
anyway,
says just simplify it.
Yeah, like it does depend on the problem. Like if you have an equation to simplify, like look for parts that might be easier to simplify first. And just like, yeah, it kind of comes with practice. Like the more simplifying problems you see, the better you'll get at it. Seems like a lot of people are curious about how many bagels Evan eats a day.
well, I will say, every week we go to Einstein Bagels and they have a promotion on Mondays that gives you 13 bagels for $8, and we get
What?
that.
Oh my
But
gosh. Is this how you get your bagels? Okay.
yeah.
Oh, those are good bagels. Meanwhile, somebody had commented, are you high school students? I'm not.
Yeah. We
But
are at
yeah,
the
we are.
moment.
Yes, I mean, like, yes, they are at the moment. I love how Vivian said at the moment, because everything is at the moment anyway. Ah, interesting. There's this, how do you break down a problem? I think I'll comment, like, when I look at any question, it always starts being complicated. And then you want to just see where is the most fragile part of it. And whenever you see it split a little bit, you get happy because it got a bit simpler. And you just keep cracking and cracking and cracking. Somebody gets 12 bagels for $5. Oh, how do you get faster at solving problems? Does anyone want to answer that one?
Oh, you know, Vivian might have better advice than me on this, but for me, fast is the same as math counts, and I just did that by doing tons of math counts problems in a row. I wasn't lucky enough to have Math Kangaroo, but I should have done more of these problems because they, I think, may be extremely creative. So it's better to do many of those fast, not like practice for specific types of problems, but I mean, types of ideas in the problems.
Yeah,
Ooh.
same basically.
There's another question which came in here. How are you guys so good at talking?
Okay, so honestly, I'll just say that like I personally am not like one of the best TAs. There's TAs who are even better at talking, and like I aspire to be like them. But basically, in becoming a TA, you kind of learn how to talk because first of all, you take improv classes, and then you like practice teaching, and you observe other teachers, and that gives you like that makes you better at teaching. I guess this is kind of in the far future for you guys because you guys are far too young to be TAs right now, but maybe in the future you should consider becoming a TA.
Yeah. The improv classes they do help a lot because they give you something to say in every situation and always something to add.
Yes, I'm going to do a plug for improv also. That's just something, improv comedy is a performance art form. And in fact, all of us have spent time taking those classes. That's actually what the high school program that we run is for. I mean, before that existed, I myself took improv comedy classes. And it teaches you how to always have, indeed, as Evan says, something to say no matter what happens. Even if your Wi-Fi breaks, you can just kind of, yes, I saw his react. That's awesome. Okay, well, with that, unfortunately, I see so much stuff coming in. Let me say this. Because there's such a flood of stuff coming in, I'm willing to have this stay for like 5 more minutes. And then after that, we'll close the whole session. But I see that there was a question here, Fiona, we gave a star. How do I get better in middle school? Because obviously these are middle school students. Any thoughts, you guys?
Wait, so in middle school, I feel like something cool about middle school is that you have a lot of free time, like compared to high school. So just like try to spend your free time well and make the most of it. Like, I don't know, you can play a lot of video games and like waste time, but you might regret that later. I don't know. Just like try to make the most of your time, and of course also enjoy it. Like don't force yourself to do math. Like find a way to also enjoy it. But yeah, just spend a lot of time, I guess.
Yeah. In fact, if I could tell myself in middle school that, it would be just that. When I do something, do it with more focus. Like do it and dedicate the whole thing to it. Even if it's not math, even if it's like playing with Legos, well, or learning about planes, that sort of thing. If you do everything you do with focus, it's like your time in the day greatly multiplies.
Cool. Let me take this other one. Somebody said they're in a situation where they know most of the things in their class. They're thinking of transferring from pre-algebra to algebra honors. Is that a good idea? And also, can they leave? So the answer is yes, you can leave. Don't worry. We're actually about to close up in 2 minutes anyway. But this algebra, pre-algebra, those are all things that help to build the foundation. If you indeed know that stuff, indeed, I don't think it's a bad thing to move forward. What else can we have here? People asked about dividing by 0. Oh.
How do you divide by 0?
That's a little bit difficult.
Yeah.
Let's finish with this one. Nava says, if I am fast but not the most accurate, how can I improve?
I'd say maybe. Oh, sorry, Vivian. You
wait,
should.
no,
go.
no, you can go. You can go.
Oh, I mean, all I'd say is start going slower and get accurate. Then you can go faster and faster because you learn a lot less. Like if you're practicing music, you learn a lot less going through super fast and making tons of mistakes than going through slowly than working it faster. And then Vivian.
Yeah. Wait, yeah, I think like just like check your work more. Like if you finish it really early, then just if you have any free time, try to check your work and do things in multiple ways, like Evan said before. But generally, like being fast, that's a good thing. Like I admire you for being fast. Like oftentimes being fast is what people don't have. So like the fact that you already have it, that's kind of good. You just need to just like work on that accuracy of it.
Yeah, it's a certain frame of mind that when you're going to do something, do it carefully. With that, I think we are basically at the time. If you enjoyed this, well, we're always happy to talk to you. And if you go to our website, you'll see plenty of stuff like this. In fact, we teach entire classes this way. But with the next live solve with Math Kangaroo in 2 weeks. So we'll see you there. Take care. Good night, everyone. We're going to
See
close
you.
out the room.
Bye.
Goodbye.
Yeah. Bye-bye.
Thank you, everyone. Thank you, Kasha.
Yep.
Yeah. Thank you.
Thank you. You were great. You are really good. And I hope you will be teachers.
Thank you.
See you
Yeah,
guys.
This is really fun. Thanks. See you.
Yeah.